Section 6-7, Inverse Relations and Functions. By the end of today's lesson, students will be able to find the inverse of a relation or a function. The inverse relation. If AB is an ordered pair of the relation, then BA is the ordered pair of the inverse. So when you find the inverse, you just switch the x and the y variable to make it y comma x. Let's look at how we find the inverse of a relation. So I give you a t-chart where you have x and y variables. To find the inverse of this relation, what you're going to do is take the x and the y values and you're going to switch it. So instead of 0, -5, it's going to be -5, 0. Instead of 1, -4, it's going to be -4, +1, sorry. Instead of 2, -3, it's going to be -3, 2. Instead of 3, -3, it's going to be -3, 3. Okay, let's graph both of these. So I'm going to graph the relation in black, so 0, -5, 1, -4, 2, -3, and then 3, -3. Okay, now I'm going to graph the inverse in pink. So -5, 0, -4, 1, -3, 2, and then -3, 3. Okay, so when you graph a relation and its inverse, it's reflected over the y equals x line. And now let's determine if the inverse or if the relation is a function. So do these 4 dots over here pass the vertical line test? So yes, the relation is a function. Okay, now let's check to see if the inverse is a function. Does it pass the vertical line test? Do those 2 points pass the vertical line test? So no, the inverse is not a function. Now let's look at how we find the inverse of an equation when you're not given points to work with. So I'm going to give you some steps to help, okay? So your first step, if you need to, change f of x to y. After you do that, your second step is going to be to switch x and y. So what we do is we swap them. So we get x equals 2y plus 8. Okay, step 3 is going to be to solve for y. Okay, so I'm going to start by subtracting 8. So that gives me x minus 8 equals 2y. Divide by 2. So that gives me 1/2 x minus 4 equals y. Okay, and then your fourth step, change y to f -1 of x to indicate that it's the inverse. So the inverse is 1/2 x minus 4. We are going to graph a relation and its inverse on the same line. So in our first example, they gave you points, and it was really easy to switch x and y. Now you need to actually know what the graph is that it's given to you, and then you can switch x and y. So y equals 2x plus 5 is a line with a slope of 2 and a y-intercept of 5. So I'm going to go ahead and I'm going to graph that. So I have 1, 2, 3, 4, 5, and then a slope of 2, so up 2 and to the right 1. Okay, so this is the point 0, 5. If I switch it, it's going to become the point 5, 0. Okay, this next point over here is the point 1, 7. So I'm going to swap it over and it's going to become 7, 1. You could find the actual inverse function if you wanted to, or you can plot what you know and then just swap the x and the y variables. So the given function is x squared minus 5. And I first want to determine the domain and the range of g of x, okay? So the domain of g of x. Okay, so since this is x squared, it's a parabola, so the domain is negative infinity to positive infinity. Okay, the range of g of x, remember those are the y values. This minus 5 means that your parabola has been moved down to negative 5. Since a is positive 1, your parabola opens up. So your range is from negative 5 to infinity. Now we are going to find the inverse. Okay, so remember your first step. Change g of x to y. Second step, switch x and y. Third step, solve for y. To undo the squared, you're going to take the square root. And when you take the square root, it's plus or it's minus. And then your last step, rewrite it. So that y is now g to the negative 1 of x. That negative 1 indicates that it's the inverse. Part C wants to know the domain for the inverse now, okay? So as long as you've written down the domain and the range of your original function, all what you have to do is swap them. So the domain for the inverse is now negative 5 to infinity. The range for the inverse, again, you swap them, so now it's negative infinity to positive infinity. The last thing this problem wants to know is the inverse, so g to the negative 1, a function? Okay, so let's look at the function that was given to us. We have plus or minus the square root of x plus 5. This plus or minus is going to cause this graph to fail the vertical line test, so no, it's not a function. Now we are going to look at composition of inverse functions. So when I give you this rule, assume that f and f to the negative 1 are inverse functions. So the inverse of f of x equals just x. And f of the inverse of x also equals just x. Our last example is going to be doing compositions of inverse functions. So before we can do compositions of them, we first need to find out what the inverse is. So first step, remember, change h of x to y. Second step, switch x and y. Okay, remember there's an invisible 1 underneath this, so we're going to cross multiply. So I have x times y plus 2 equals 4. Okay, so that is going to give me xy plus 2x equals 4. Now we have to solve for y. So I'm going to subtract the 2x. And then I am going to divide by x. And that is our inverse, so therefore we are going to rewrite this as h to the negative 1 of x equals 4 minus 2x divided by x. Since I had to move to a new slide at the top, I just wrote what h of x was and the inverse was. And now we want to find h of the inverse of h of 0. So I always like rewriting this, h parentheses the inverse of h of 0, because now I feel like I can see exactly what I'm trying to do. So the first step I need to do is plug 0 in for the inverse. Remember, you always do inside the parentheses first. So the inverse, and I'm plugging in 0. So 4 minus 2 times 0 divided by 0. Are you allowed to divide by 0? So hopefully you guys all said that no, you can't divide by 0. So this composition does not exist. There is no answer for it because I can't go any farther because I can't divide by 0. So let's see if I can squeeze the last part in here. So this time I want you to do the inverse of h, and then we're still going to plug in 0, okay? So again, I'm going to rewrite this. The inverse of h, oops, my bad, of 0. Again, start inside the parentheses first. So h of 0 equals 4 divided by 0 plus 2, which is 4 divided by 2, which is 2. So now I can move on to this second part where I'm going to plug that answer into the inverse. So the inverse of 2 equals 4 minus 2 times 2 divided by 2. Okay, so 2 times 2 is 4. 4 minus 4 is 0. And 0 divided by 2 is 0. So remember on the other slide, we wrote f of the inverse of x equals x. So in this problem, they gave you 0 in the place of x, which is why my answer is 0. Now, when you do this on a quiz or a test, you do have to prove to me that it is 0. You can't just write equals 0. And then also remember you would need to check because sometimes it doesn't exist.